Hello, everybody. Hope everyone's doing well. Thanks for tuning in to Graphing Linear Equations. Let's get after it. So what we need to know is this formula right here. Y equals mx plus b. This is the formula for any linear equation. Okay, so this is a linear equation. Now, what that means is linear equations are equations that make a line, which is why it has that word line in the word linear. So linear means an equation that when you graph it on a coordinate plane, it'll make a line. So they would be in this format, y equals mx plus b. Now, in y equals mx plus b, there's a couple very, very important pieces here. The m represents the slope of that line, how steep it is. The b represents the y-intercept, also known as the initial value or the starting point. There's a couple of things that we refer to. The y-intercept, you can say starting point, you can say initial value, but it is known as the y-intercept. Now, what the y-intercept is, you guys, is where a line crosses the y-axis. So here I have an xy coordinate plane. I'm just drawing a real quick sketch here. And on an xy coordinate plane, when I draw a line on it, that point where it crosses this y-axis, that is this value, the y-intercept. Intercept means to cross. So this is where the line is crossing the y-axis, which is why we call it the y-intercept. Now, slope. The formula for slope, we've already learned a couple different formulas for it. We've learned change in y over change in x, which is totally right. Yeah, that's what it is. Slope is change in y over change in x. We've also learned that slope is rise over run. So when I'm looking at a graph, it's nice and easy to count the rise and the run. That's how I find the slope. When we're looking at a table, it's nice to find the change in y and the change in x. Well, also another formula for slope that we haven't really looked at yet is this one. And this is just another way of writing change in y over change in x. So you're taking the y coordinates of points and you're subtracting them, and you're taking x coordinates and points and you're subtracting them. That tells you the run and the rise, or it tells you what the change in x and the change in y is. Another way that you can look at this, and this is sometimes confusing people, which is why I always show it both ways, is you could also have y2 minus y1 over x2 minus x1. That's the same thing as y minus y. But what that is this is really what we use if we're looking at 2 points. So let's say I'm asking you, hey, what's the slope between the points 1, 2 and 3, 6? And I said, here's 2 points on a graph. What's the slope? So these are 2 points that are on a graph. What's the slope of this line? If I were to graph these and draw a line, what would be the slope? So the way we use this formula is we just plug in our y value. So this would be the second y. This just means y2 of the y of the second point, x of the second point. So this would have been like my x2 and my y2. And this would have been my x1 and my y1. So we're just plugging in, I'm just subtracting my y's and I'm subtracting my x's to figure out the change in y from here to here and the change in x from here to here. So by doing that, I subtract. So 6 minus 2 would be 4, which makes sense because from 2 to 6 we went up 4. So that just gives me my change in y. 3 minus 1 is 2. And we look up, we go up 2. So that'd be my change in x. So it's just subtracting the second y from the first y, the second x from the first x. And that's just that's a formula that you might see for how to find the slope. And then slope-intercept form is your other term. And then this, again, we've already talked about it. This linear equation is also known as slope-intercept form because you're given the slope and then you're given the y-intercept. Okay, we just unpacked a lot there, but we're going to go through a word problem. We're going to look at a table, and then we're also going to graph, and we're going to show you how we use slope-intercept form. So, for slope-intercept form, we know M is our slope, and we also know that B is the y-intercept. Now, what we're going to do is whenever we're looking at a word problem, the slope is always the rate of change, so it's whatever something is changing within that word problem. And then the y-intercept is the initial value or the starting point or the one thing that's constant. Or not necessarily constant, I'm sorry, that was not the right term, because our slope is a constant rate of change. But it's the one thing that maybe isn't dependent upon something else, so we're not multiplying it by anything. So a phone salesperson is paid a minimum weekly salary and a commission for each phone sold. So that commission for each phone sold, that's going to be my slope, because that's the part that's going to be different each time. They might sell a different amount of phones each week, but this is their base salary. This is not going to change. This is always going to be the same. So what we want to do is we want to confirm that the relationship is linear and then give the constant rate of change in the initial value. So our initial value is going to be the minimum weekly salary, because that's where no matter what, every week they're guaranteed to make that money. So that's always going to be a starting point for them and how much money they make a week. What's going to determine how much money after that is how many phones they actually sell, because that's what's going to increase how much money they make. So I have a table. So if they sold 10 phones, they made $480. They sold 20 phones, $630. 30 phones, $780. 40 phones, $930. Now right away you can notice that it's definitely not proportional. If I did 480 divided by 10, I get 48. 630 divided by 20 is not 48. So that would not be proportional, but that's not what we're not looking for proportionality. We already know it's not proportional because of this plus B part right here. So what I want to do is figure out what was my rate of change constant. So remember, that's change in y over change in x. X is always on the left, y is always on the right. So my change in y, I go up 150. It looks like it goes up 150. Up 150 each time. And my change in x is 10. So they're making $150 for every extra 10 cell phones they sell, which is $15 per one phone if I find that unit rate. So their slope is $15 per cell phone sold. We know already that x represents the number of cell phones sold. So we know that y equals 15 times x, because x is the number of cell phones sold, and they're making $15 for every cell phone they sell. Y is how much money they make every week. That doesn't tell me, though, what their weekly salary is. So what I can do is, the trick with finding the y-intercept when looking at a table is we go backwards in our table until we have x is 0. Because when x is 0, that tells me, okay, well, if they sold no phones, how much money would they make? That'd be their starting value. That would tell me their initial salary. So I can go backwards in my table. I was counting up by 10 each time here. Well, if I go down 10, that would take me to 0, which means I'm going to go backwards here. I was going up 150 each time, so I can go backwards 150. And 480 minus 150 is 330. So that tells me that when x is 0, the y-intercept is $330. So that means their weekly salary is $330. And when they sold 10 cell phones, they made $480 because they made $15 for every cell phone that they sold. So 15 times 10 is 150 plus 330 would give me that $480 they made that week. So the base salary, this is where they start, and this is how much money they make per cell phone. And this whole thing should be right here under equation. Sorry guys, I kind of skipped the wording there. The salesperson receives a salary of $330 each week. Okay? So, initial value, your y-intercept. The hardest part is always when your x is 0. It's always when x is 0. And the reason why is, if we talk about a graph again, we said that it's when a line crosses the y-intercept. At this point right here, x is 0 on the y-intercept. Okay? X is always 0 because over here it's -1, over here it's +1, but on the y-axis, x is always 0. So that's why in a table, if we can figure out what y is when x is 0, we can find our y-intercept. So let's look at another table here. I'm going to look for the slope, I'm going to look for the y-intercept, and then I can write my equation for slope and y-intercept. So, change in y, change in x. Right? That's how we figure out what my slope is. So my change in y looks like I'm going up 10 each time. So it is constant, which is good. Change in x is going up 2 each time. So change in y over change in x, my slope is 10 over 2, which can be simplified to 5. So we just figured out the rate of change or the slope is just 5. You could put 5 over 1 because that shows the rise and the run, but there's no need to because we know 5 automatically has a denominator of 1. So now I want to figure out the initial value of the y-intercept. So if I'm looking for the y-intercept, I got to go my table backwards until I get to 0. So if I go backwards 2, I'll get x is 0, which means I got to go backwards 10 to get 12. So my initial value is 12. So now I can write my equation. Y equals slope times x, 5x, plus or minus my y-intercept, which is 12. And I'm done. Now what I want you to look at is we are also going to be graphing these lines. So what we're going to be doing is you're going to look at an equation. You're going to be expected to graph it right away. Not right away, but you're going to be expected to graph that equation without having to even make a table. So if I ask you guys, and we've done that before where we've looked at a table and we've had to translate this to a graph, but right now I'm looking at an equation. I want you to translate it to a graph. So here's the cool part. We know that this y-intercept, we already know what point this is. This y-intercept is where the graph crosses the y-axis. So my y-intercept is -1. Well, here's my y-axis. Here's -1 on my y-axis. There's a point on my line. That represents the y-intercept. This is the y-intercept. It's where the graph crosses the y-axis, and it crosses it at -1. So there's a point. Now, from this point, I get to use my slope. We know the slope is 2 over 3, and that's a rise of 2 and a run of 3. So that means from here, I'm going to rise 2, 1, 2, run 3, 1, 2, 3. So I went up 2 over 3, 1, 2, 3. I can go up 2 again, 1, 2, 1, 2, 3, over 3. And I can go the opposite direction, down 2, 1, 2, 1, 2, 3. And this way works as well because if we look, I went down 2 over 3 to the left. I went opposite. This would be -2 and -3. Going left is a negative direction. A negative over a negative. If my rise was -2, my run was -3. A negative over negative equals positive 2/3, which is why this still helps me make a positive slope. Notice how I can keep going. Whoops. I can keep going and I continue to make a straight line. As soon as our line isn't straight anymore, we know we did something wrong. Because there's my line. Up 2 over 3, up 2 over 3, up 2 over 3. I made a positive slope because I'm going uphill from left to right. That's a good check to make sure we didn't mess it up. Okay, guys. A couple things to remember. Y equals mx plus b is a big one. Okay, y equals mx plus b. And then you also, I would say, and I would label what these are, and y equals mx plus b. Also, another important thing to remember would be the y-intercept is when x is 0. That's big. The y-intercept is when x equals 0. Okay, and that's big for when we're looking at a table. Okay? Try these ones. Okay, give these ones a shot, see how you do, and we'll talk more. We'll get some more practice in on this. Okay, guys, thanks for watching. Gradius out.